Welcome to another episode of the Pilot Talk podcast by OSM Aviation with Captain Michelle Treskin and myself, Stein Mjottveit. We're two commercial pilots and flight instructors with a shared passion for aviation and the aviation industry. The Pilot Talk podcast is made with the ambition to inspire, educate, and entertain you, our beloved listeners who either share our passion for flying or simply want to get a peek behind the cockpit door. In this podcast, we will discuss flying, flight training, career advice for pilots, and other interesting topics from the exciting world of aviation. And in today's episode, Michelle, we're going to talk about what?
We're going to talk about electric airplanes. We're going to talk about the E-Flyer, the one that we have bought for OSM, Flight Academy.
That's exciting.
Oh, yes, absolutely. Well, we have two special guests.
Yeah.
The first one is George Bye from Buy Aerospace. He's the CEO of Buy Aerospace, and he's the one that designed, if you want, with his team, the E-Flyer 2, which is a two-passenger training airplane. Electric, fully electric.
Yeah.
Zero carbon emission. CO2.
That's so exciting.
Yeah, I mean, it's like talking to Orville Wright.
Yeah,
now.
yeah.
I mean, it's incredible.
He's truly a pioneer. Within
Yeah. He's
aviation.
a pioneer. He's the spearhead, if you want, of electric airplanes. Incredible.
And who else do we have on the show?
He won't. He's going to be with the live through the telephone.
Yeah.
Now we're going to have a phone patch sort of thing with him. But it's Tony Thompson from Quantum.
Yeah.
In California.
Yeah, he's the president of Quantum.
That's right. Yeah. And he has bought 100 E-Flyers from George, and he will be talking about his vision about this new commercial venture that he's implementing in the South California at this time.
Yeah, it's very exciting. It's like, it's urban mobility revolutionized.
Exactly.
And Bye Aerospace is making it possible through the much more cost-efficient E-Flyer 2, and then the E-Flyer 4 is going to come shortly.
That's right.
They also have another model in the works. So, we're sitting down with these guys. They're pioneering electric aviation in their individual ways, and we're collaborating with both of them. We're also have an order of E-Flyers, and we're also training pilots for Quantum. So this is going to be a great episode. I'm really excited.
Yeah. So stay tuned, and you're going to love this one.
Yep. Electric aviation starts today.
Yay.
You are listening to Pilot Talk by OSM Aviation.
Okay. So who do we have in front of us today?
We have the most special guests, one of the most important people of the 21st century, I think. We have the George Bye, who is the CEO, President of Buy Aerospace. And what a pleasure, what an honor.
Thank you both. Thank you very much. It is indeed for me as well.
Thank you.
That's nice. Would you want to explain a little bit more about who George Bye is?
I'm an engineer and a pilot, a professional pilot, a military pilot first. I went through the Air Force for many years, trained fighter pilots in a special program in the U.S. at Shepherd Air Force Base at NGEPT. Then from there, went into industry after Desert Storm and spent some years with Raytheon Flight Safety in a T6 turboprop development program. Had a couple of years sometime later with Boeing on the TX Advanced Jet Trainer Program. So I've kind of been developing trainers for the military with industry, along with being a trainer myself in the Air Force for years. So my life journey as an engineer and as a pilot really has all kind of come together and led to Bye Aerospace and, of course, the E-Flyer.
That's amazing. We are, as you well know, very excited about the E-Flyer. We've talked about it on many episodes before, and we can't wait to take part in this revolution. Yeah. And I got to tell you, George, it sounds like you have, based on your background, a very, very unique set of experiences to be able to, make the next generation of training aircraft.
It is unique. I'm very honored and humbled to be able to do this, but I also see it as kind of a legacy. It's important to do for our industry. It's not just an interesting thing to do.
Absolutely. Yeah, absolutely. Well, it's the future, isn't it? I mean,
Indeed, and electric has so many advantages. It's not perhaps intuitive that an electric car could be an electric airplane. But in time, as the technologies evolve, the benefits and the translation of that technology are becoming more evident.
Right,
And that's been our task. That's been what we've been doing for the last 10 years.
right. Have you, when you designed the, again, I don't know that much about about electric airplanes, but when you design an electric plane and you design an electric car, there's some subtle difference between a normal car and a normal piston, normally aspired airplane. Do you have the same technology where when you reduce the thrust, the power, the engine will recharge the battery just like a normal, like an electric car, something like that?
So the braking regenerative
That's right.
ability for hybrid cars, electric cars,
Right.
is something that we can do on airplanes. The propeller becomes a windmill when you're decelerating or descending.
That's right.
So you can put energy back into the batteries as that is occurring. Perhaps more importantly, though, an electric airplane doesn't idle.
True.
Think about that for a second. So when you start a conventional airplane, of course, there's mechanical resistance to overcome. You have to idle, and there's fuel consumed rather inefficiently. In fact, while you're idling, it's the worst case scenario of combusting fuel. Idle is not efficient at all. And so all the while you're taxiing, you're on the ground, etc. You're not operating economically efficiently.
Yes.
An electric airplane, on the other hand, only uses energy, only uses torque to move the airplane. So you overcome rolling resistance, and that's it. You come to a stop at an intersection, the
propeller stops.
Propeller stops.
Right.
So the energy use is just as efficient on the ground, only for the required movement, as it is in flight. Again, only when you're trying to sustain flight. When you're trying to descend or decelerate, again, the motors, there's no idle. It simply is putting energy back into the batteries at that point. So the overall concept of flight, if you ponder it, you kind of rethink, oh my goodness, there's so much more opportunity here. It's not just electric versus internal combustion engine. There's much more to it.
Right. So there's no idle descent on an electric plane.
That's right.
So basically, if you do, again, I'm trying to fathom the concept. So basically, if you do a rapid descent and you don't want to use the power, will the propeller stop and just the aircraft will descend?
Indeed.
Okay.
That's exactly what will happen.
Okay. So when you design, I'm sorry, Stein, I'm going on it here. It's such an interesting subject. Now I know that we are time constrained, because I'm also an ex-military trainer and stuff. So did you have to change? Do you have to change the syllabus of training compared to a internal combustion engine training? You know, the stall recovery, the things like that, where you use full power or use idle power to recover from a nose low, unusual altitude sort of thing. Do you have to change the syllabus for that, or?
Oh, there are many benefits to the syllabus with electric, but one of them isn't the flying fundamentals.
Right.
When you recover from a stall, you're recovering from a stall.
Right.
When you're doing slow flight, when you're doing turns around a pylon, when you're doing touch and goes, all the traffic pattern disciplines, that's all the same.
Same.
So you are learning airmanship as every pilot should indeed learn airmanship.
Okay.
On the other hand, you don't have the negative learning, and I say that with respect, but you don't have the negative learning of an internal combustion engine airplane that doesn't necessarily translate into a turboprop or a turbofan that you're going to experience as a professional pilot.
Right.
In fact, an electric motor is much more similar in terms of torque and temperature to a turbo fan or a turbo prop than an internal combustion engine is. And when we're trying to train students about flying and airmanship and, controlling the airplane, communication, navigating, etc.
Right.
Flight path management is not carburation and magnetos and so forth.
Right.
It really is a focus, much more efficient focus on the flight training mission for the new pilot with electric, as opposed to the older legacy aircraft.
So the training, basically, the training curve will be much more easier for to
Transition.
train the transition.
Indeed, yeah.
One of the advantages.
Yeah. And when it comes to efficiency, I know that this has been mentioned before as well. The maintenance will be less moving parts, right?
946 moving parts, some say, in a Lycoming.
Yeah.
It depends on, I suppose, what you count. One moving part in an electric motor, and that's pretty
That's
much
a
a
big
great
difference.
summation, yeah,
That's
and the kind of maintenance you can expect.
Pilot Talk with Stein Mjotvedt and Michelle Treskin.
And then we also, we've discussed this before, the responsiveness of an electric engine. We're expecting more of that, just like Michelle said, compared to an electric car. They're more responsive on the throttle,
Indeed.
but also more efficient, right? Because you don't need that air to compress for combustion. So you'll have a better power distribution as you gain altitude as well. Is that correct?
Indeed, there is no combustion in electric. So air density, the effects as you climb are trivial. They would still affect, of course, airfoils, propeller foils, airfoils.
And
So to some extent, there's a impact. But just as an example, our E-Flyer prototype aircraft at 10,000 feet, 10,000 feet, 70 kilowatts motor power, climbs at 750 feet per minute
At 10,000 feet.
at 10,000 feet.
Wow.
Nice.
A Cessna 172 at sea level on a standard day can't climb at 750 feet per minute. There you go. Okay.
Yeah, yeah.
Will temperature affect the performance of the electric airplane?
Temperature affects everything on every airplane,
Right.
depending on how extreme it is. And electric's no different than anything else. So temperature management within reason is something, of course, thermal management, we say,
Right.
is something that we pay attention to for battery performance and motor performance.
Yeah. I'm thinking about if you sell your if the E-Flyer is required up north, like in Canada, where it's nice and cold in the wintertime, will there be some restriction with temperature and things like that?
Again, no different than any
listen.
electric vehicle or ground-based vehicle. The first flight of the day, there's block preheating. You plug them in and warm them up,
Yeah,
and you're on your way.
Yeah.
incredible.
Yeah, it's good. And that's, speaking of charging, that's also a question that many people ask themselves when it comes to electric planes, how the charge time will be in between flights. And I heard you talk about this before. It sounded pretty impressive to me.
About 20 minutes.
There you go.
Yeah,
20 minutes.
So a typical training sortie, as, again, we're all well familiar, 1.1 to 1.3, maybe 1.4 hours, depending on, again, the particular student and the mission and so forth.
Yeah.
2/10, maybe a little bit more of that's maybe 3/10 is on the ground taxi portion. And then the rest, 1 hour or thereabouts, a little bit more maybe, is actually in the air. And student saturation's reached, and you're trying to bring student back home again and get the next student on their way. And that energy consumed is about 0.3 C of the battery pack. By that I mean 1/3 of the battery pack's been used, maybe 4/10 or a half even of the state of charge has been used. Refilling that at 1 C at the full capacity of the battery pack to absorb energy takes about 20 to 30 minutes. So depending on if it's been a little bit shorter or a little bit longer mission, between 20 and 30 minutes, which is a typical turn time between sorties in any case.
True.
And that's provided that the avgas truck actually shows up timely, which if it's a busy afternoon, you may be waiting there a while.
You're right.
So the ops tempo rhythm with electric should be just fine.
Wow. Is that technology compared to the electric car charging?
Oh, indeed. Yeah, it's a level 3 charger.
So it's the same thing, isn't it? Incredible.
Which, of course, is well known now in Norway, much of Northern Europe, Scandinavia, parts of the U.S., California in particular.
Yeah. There's a lot of things have been done to incentivize the use of electric propulsion, ground-based vehicles. So we're expecting this to be well received in Scandinavia as well when we get electric planes
It'll be nice to have.
into training operations. Yeah.
Absolutely.
Anything else you want to mention about the efficiency? I know.
Well, I think one of the things that's really important is, of course, the operating cost of the airplane. Efficiency translates to, operating efficiency and energy efficiency. We convert electrons into torque, and the cost of those electrons is remarkably less than the cost of the carbon-based fuels that legacy airplanes use. So, happily, the E-Flyer's 5 times less expensive to operate than a legacy Cessna or Piper or Diamond. That's a big deal. No CO2 is very exciting, very important.
Absolutely.
Very little noise, but the operating cost changes the paradigm of flight training for every aspect of the participants, from students to owners to maintainers. That is huge.
It really is. And, this ties into our vision as well of making flight training more accessible to more, which includes making it more affordable. Obviously, making the investment to start using electric planes is a really sound investment from that perspective, and we're excited about it.
Oh, it's a smart way of doing it.
Yeah. And also, the airframe is going to be composite. So what's the weight compared to a traditional, conventional?
So the airplane weight overall is about the same, maybe slightly less.
Yeah.
The airframe weight is less, but the total weight of the plane, the gross weight's about on par with the legacy.
Because of the battery, right? The batteries are pretty heavy.
Yeah, so battery, motor, roughly the same as an engine and fuel. Structural weight, a little bit less, a little bit more for this, a little bit less for that. We end up just about the same kind of typical flight trainer weight, 2,300, 2,400, 2,500 pounds.
Yeah. Gotcha.
That's great. And what's the maximum useful weight can you put in the aircraft?
So for the E-Flyer 2, it's 450 pounds.
450 pounds.
So nice, comfortable, pilot, student, and
Perfect.
bags and whatever,
And you're coming up with a 4-seater.
Correct, E-Flyer 4.
Wow, that's exciting.
Yep, E-Flyer 4, absolutely. And fully Part 135 compliant, which gives great flexibility. So for IFR, IMC training, but also for full use and utility for hire purposes.
Right. And compared to the dimension of the E-Flyer 2, the 4 is quite much bigger airplane.
It's a full 4-seater, and dimensionally the cabin is very roomy, a 46-inch wide cabin.
Oh, that's pretty big.
And very, very comfortable indeed. A lot of our aircraft, they were designed a few years ago, and people in general back then were somewhat smaller than they are today. So
and you're looking at me.
It's no comment. No. But I'm just saying we're all
different shape and different size.
The legacy airplanes, a lot of them go back. The fleet averages almost 50 years old.
That's incredible, isn't it?
And airplanes going back that far, it's hard to imagine. I mean, just saying that out loud, it's hard to imagine. But 30 8.5-inch wide cabin in the Cessna 172. I mean, that is an uncomfortable training environment.
tight.
It's just tight.
Yeah.
So you add nearly a foot wider, and you have a much more comfortable training environment. And again, you can focus on student training rather than, gee, I'm uncomfortable because I'm shoulder to shoulder.
And that is so important, I think.
I sure look forward to that additional space. You know,
Yeah,
6'2", and you know the Cessna.
You don't have elbow.
Yeah, the 172 is fine, but we did some training in the 152, and that becomes very.
Oh yeah,
You're
it's
sitting
just
shoulder to shoulder.
Totally uncomfortable. I mean, it's not good. What's on the now that we've got the E-Flyer 2 and the E-Flyer 4? What do you see in the future?
Well, there's definitely more to come. We view the expansion of the market to be an expansion of the technology. The trends in our engineering process with the batteries and the motor will really allow a larger airplane to be unveiled here very soon. We see a 9-seater coming before long. It will be kind of a King Air size of an aircraft.
Multi-engine?
Twin, yeah. So we're very, very excited about that. But I think it should come as no surprise that as the technology readiness and maturity for the 2 is enabling the 4 to follow, that as that indeed continues to mature, that what will follow will be a further progression. And the advantages are the same. Again, no CO2,
Right.
noise benefits, and it turns out at that scale, it's still a 5-fold operating cost benefit.
Yeah.
And that's disruptive. I mean, that is just plain change the world disruptive.
Totally agree. When do you see the technology going to the point where we will be replacing the big boys with the electric airplanes?
Well, that's. It turns out it's harder to do. I can progress pretty nicely in general aviation from 2 to 4, again to, like I said, kind of the soon to be announced 9-seater. But the problem is drag goes up with velocity squared, and to go faster, it's a squared problem, not a linear problem.
Sure.
So people like to go, well, gee, what about the jet? You know, tell me about the, commercial jet. When's that going to happen? And it will eventually in time, I'm sure, in due course, but that'll be much farther down the road than the piston and turboprop realm, because you can get call it 120 to 180, even 200 knots. You translate that up to altitude, and again, electric likes altitude, doesn't care. So you have the density altitude translation to true airspeed, and so you can get some really reasonable numbers in the in the teens and 20s. The problem is when you get beyond the realm of a prop and into a fan, a turbo fan kind of operation, and Mach numbers rather than true airspeed kinds of numbers, that gets harder to do because drag goes up. It just really hits you hard.
Right. And you can't really replace the internal jet engine with a electric motor at this point today to generate that fan and the turbine sort of thing. And, wouldn't be a turbine at that point, but to generate that kind of thrust.
Indeed, even a turbo fan has the very hot air that is providing a significant amount of thrust at altitude in those cold temperatures. And turning turbofan blades, of course, you can do with an electric motor, but you're missing that heat energy that's still providing some of that thrust.
That's true. It's something that I guess we probably won't see in our lifetime.
Well, perhaps, I don't know. I mean,
you never know.
We'll tackle that in the next podcast.
I'm an old guy.
How about that?
That sounds like a good plan, eh?
That's great.
There's some fun things coming, but we'll get there.
Looking forward to it.
Yeah.
Absolutely.
And I'm very curious, George, about this. You're a pioneer. You're at the leading edge of this revolution, and what is the environment like here in the U.S. now? Is the FAA incentivizing these type of developments on a federal level? How is that collaboration going, or are you guys the ones spearheading it?
Well, I think as with any pioneering effort, you have the benefits of being first, and then you have, of course, the challenges of being first. There is no roadmap. There is nobody saying, here, George, follow me, I'll show you how to do this. The team, we've got a fantastic team, our leaders, our engineers, and of course the FAA, along with the EASA, are both very motivated for a clean, high-tech future. Yeah. They want this to happen. On the other hand, they don't have a roadmap for this to happen either. So we're working together with them to create that future pathway for how electric aircraft will be certified, how they'll be brought to market, how they'll be maintained and kept safe for the public. Student pilots want to know that, and their spouses want to know that they're training in a great airplane, a very safe airplane. And indeed, electric has the opportunity to be safer than anything ever before imagined.
Absolutely, absolutely. I've got a question real quick, because again, it's aerodynamic, but the wingspan on the E-Flyer is quite long.
It's over 38 feet. Yeah.
Is it something that was intentionally done because of if there is a failure of the engine, the aircraft will have a better glide ratio than a normal aircraft?
The benefit of the aerodynamics on the airplane is substantial. We have twice the aero efficiency of a Cessna 172.
Yeah.
Over 20. Cessna, of course, is just 9.6 or thereabouts.
Not very good.
Not very good.
No.
So the idea there, of course, is for safety.
Sure.
But secondly, aero efficiency is something that we're seeing translate into every airplane now. Higher aspect ratio wings is standard.
Right.
2/3 span flaps is standard. We are looking at higher efficiency aircraft because that is the trend that everybody must follow. We all have the challenge of greater efficiency.
True.
So this airplane is designed more in line with all aircraft in development with that trend in mind.
Yeah, with the winglet as well. Yeah.
Indeed.
Yeah, great design.
It looks really sleek.
Excellent.
Speaking of an exciting future, we're gonna give Tony Thompson a call, bring him into the studio via phone. He's the president of Quantum, and they have also placed an order of some E-Flyers. So we'll see what you guys. We'll get into more. Talk some more about the future of electric aviation here. So.
All right. Okay. Yeah, Quantum got, we bought, I think that we have 60 airplanes, and Quantum has over 100, if I'm correct.
They have quite a few. I'll let Tony talk about his orders.
Let's see if we can get him.
Hello, this is Tony.
Mr. Tony Thompson, welcome to the Pilot Talk podcast. How are you today?
Great, thank you. How are you?
We are great. We're sitting in Denver, Colorado, here with George Bye.
Hey, Tony.
Hello, George. How are you?
Very good.
All righty. To give you a bit of background, Tony, we've started off talking about the very exciting E-Flyer 2 and E-Flyer 4, and well, maybe you can start off by telling us a little bit about yourself and about Quantum. That's a good place to start, eh?
Good place, yeah.
I'll start a little bit with myself. I have a couple degrees from MIT in aeronautics and in physics, and I have been an aviation enthusiast since I was a little boy. And I have been following aviation for years and for decades, in fact. And about 10 years ago, maybe about 7 or 8 years ago, I identified electric aviation as the next big thing. And of course, George Bye is the leader in electric aircraft. And I was just thrilled when I learned that he was developing the E-Flyer 2 and the E-Flyer 4. And so Quantum is doing business now with George Bye and Buy Aerospace. Our relationship began about a year ago. We're going to be flying their E-Flyer 2 and their E-Flyer 4 and some more advanced aircraft, and we just couldn't be more excited about that.
Well, that's great to hear, and thank you for that introduction, Tony. It's for me and Michelle here. It's a great honor to have the two of you talking about electric aviation. It's very, very exciting what's happening in this space.
Absolutely.
Yeah, and but could you? How many? When do you plan to start using the E-Flyer in your operations, Tony? And then can you tell us a little bit more about how that's going to look?
Well, the answer is as soon as possible. As soon as George is approved by the FAA, and he's well on his way to getting FAA approval. As soon as the FAA approves it, and as soon as George can produce the aircraft, we will start flying them commercially. And we anticipate that to be at the end of next year, starting with the E-Flyer 2. We'll use it for air taxi routes, for commuter routes. It's a two-seater, of course, and I am certain that there are many customers who would enjoy the privacy of a two-seat aircraft. There are tens of thousands of super commuters in the LA area and in the San Francisco Bay Area, and they're all just dying for a solution to that. And we think George's aircraft is the perfect solution for that. And so, again, the answer to that question is as soon as possible, and we believe it's going to be at the end of next year. That's when we'll start flying them.
Yeah, it sounds like you are as eager as we are.
Exactly.
Yeah, me too. Me too.
I think that's correct. Yes, we may end up having a little war over the aircraft.
That's right.
That's brilliant.
But it'll all be a little friendly fight.
I think so too. And just to connect everything together, we are also looking to collaborate. Tony, OSM Aviation Academy is going to train pilots to operate for Quantum, which will be a great asset to the pilots going through that program. They will already be intimately familiar with the aircraft once they start operating for Quantum.
That's right.
Yeah,
It's a great synergy.
Yeah.
Yeah, it's great synergy, and that is the primary reason why we developed a relationship with OSM, so that our pilots can be trained in the very aircraft that they're going to be flying commercially. A pilot that is intimately familiar with the aircraft, with its systems, and how it handles is a safer pilot.
Absolutely.
And safety, of course, is crucial in aviation, and we intend to set the highest standard possible for safety. And we're really thrilled with our relationship with OSM because we believe OSM is going to certainly help us to do that.
That's great. We're very excited too. And I think, now that we have both of you here in the studio, we shouldn't squander the chance. What are the most exciting things developing right now? And what do you see on the horizon when it comes to electric aviation and the market for this type of commuting? What do you guys have to say about those things?
George, I'll let you go first.
Well, clearly there is a gigantic demand for new pilots, and the right time for the new technology, the benefits of electric, couldn't be better picked. I mean, this is the time for this market, for this airplane, starting with the two, of course, for that pilot training aspect, going to the E-Flyer 4 for the fully Part 135 compliant, so you have complete for hire abilities in the marketplace, and that's of course what Tony's going to go from the 2 to the 4, and then of course to follow the advanced aircraft that I was mentioning a few minutes ago.
Yeah.
The 9-seater that we'll be announcing soon is very, very much a part of that full portfolio of opportunity. Right time, right technology, and a fantastic and very disruptive benefit to the operating cost.
Yeah, absolutely.
Tony, would you agree?
I would agree, and to follow up on that, George touched on the massive demand for new pilots, and his aircraft will certainly solve that problem, but there is just as massive of a demand for a solution to the mobility problem that we have here in America, particularly in California, in Los Angeles, in San Francisco, Atlanta. Many parts of America have a mobility problem.
True.
Our cities are growing, our infrastructure is aging, and people spend hours and hours and hours of their day commuting to work. There are stories in the Bay Area of people commuting 4 hours. These aircraft are an ideal solution to that problem. Their operating costs are much lower, and so it's now economically feasible to fly people to work from their local neighborhood airport where they live to the local neighborhood airport to where they work. And we believe that is just a massive, massive economic opportunity for us, but also a massive benefit to the community. We can save workers hours and hours of time per day. That means more time with their family. That means better health. That means better commuting for the environment. As George said, it's just the right time for this technology for so many reasons.
Absolutely. Less pollution and all that. I mean, it's all green.
No CO2, no combustive fuels. Yeah.
Beautiful.
Okay, so one of the things one of the challenges we face, I should say, is that there's somewhat a lack of diversity in our industry, and it's also very male-dominated.
Absolutely.
So not enough women. We'd like to see more diversity, more women. Is that aligned with your perspective, Tony? Could you tell us a little bit more about why that's important?
Yeah, that is in line with Quantum's perspective, and there is indeed a massive pilot shortage, and it's only going to get worse if we don't do anything about it. And the clearest way to do something about it, of course, is to open up our pilot corps to the half of humanity that historically has been excluded, and that is women. And so Quantum and OSM have gotten together and formed a partnership whereby OSM will train pilots for Quantum with an emphasis on being inclusive, including women in our outreach efforts, including minorities, and including all groups of humanity to become pilots. And we believe that is the best way to address the pilot shortage. We believe it is the right thing to do, and we believe it is the safe thing to do. Clearly, if you want to get the best and the safest pilots, then your search for pilots should include all of humanity. And Quantum and OSM are perfectly aligned on that. We share the values that inclusivity and diversity is the answer to the pilot shortage and is the answer to increased safety in aviation.
Amen.
Wow, that was very well said, Tony. I can't
Really good.
I can't tell you how much we agree with that perspective, and that was very well said.
Very well said, and right to the point. I mean, you're totally right on that thing. I mean, it's just so much that a lot of doors are going to be opening.
Yeah, and there's no way we're going to be able to solve the pilot shortage unless we make it accessible to more.
To everybody.
Yeah.
Yes. Yeah, not only is it the right thing to do, but it's good business. Yeah. And that's often the case, of course. The right thing to do is often good business, and it is certainly so in this case.
Yeah.
I totally agree. Totally agree with you, Tony.
All righty.
That's great.
I really like the visionary thoughts that you guys present when we're talking about these things. It's all about, it's not just it's a cool plane. Any pilot will agree to that. It's got huge benefits in terms of cost efficiency and so on. But you guys are thinking in ways that how will this, benefit the greater community. And what I find really exciting about this is that it sounds to me like it has the potential of creating a whole new ecosystem of connectivity through aviation. So it might even increase the need for pilots even more because a whole new market will grow out of it. Like you say, Tony, it might be feasible now to take an aircraft from, Santa Monica to Van Nuys or to Burbank and anyone who's been in Los Angeles traffic
know what it is.
Know that it would be nice to do that.
And it's affordable. It'll make it more affordable to more people. And you're introducing aviation to other people that maybe never thought about going to an aircraft.
And using an aircraft. Less expensive to fly than it is to drive. Not to mention the time savings.
Yeah.
And of course, no CO2 is produced in the process.
That's great.
That's huge.
Yeah, and to follow up on the idea of this technology creating new markets, I touched on using it to help commuters get to work quicker, but there are so many other applications. For example, a lawyer could take his client to lunch from Santa Monica to Santa Barbara a little 2 to 2.5 hour lunch by flying there. Currently, it's just not practical to go from Los Angeles to Santa Barbara for lunch. It just takes too long to drive there and drive back. But we can now fly there. And so that's a whole new market, these little destination routes from Santa Monica to Santa Barbara for lunch, or even from Santa Monica to Las Vegas for lunch or for a night show and back the same night. It's currently not feasible to go see a wonderful Cirque du Soleil show from Los Angeles to Las Vegas be back the same night. The traffic is just awful and it's too far. But now it's possible. So we've got all these great new markets that are opened up.
It's exciting.
Wow. I'm all excited.
Yeah.
I can't wait to do it.
Yeah. What do you think, George? Do you see any leaps in terms of technology moving forward for electric airplanes? I'm thinking about batteries here. I know there's a lot of talk about this, and many things have happened in terms of the...
We have a battery technology that we're working on with a company called Oxys, and Tony will be the direct beneficiary of that in this first, this new technology airplane I was just mentioning a minute ago. That will double the energy density of the battery pack. So twice as much energy per unit weight as what we have today. That's what enables that new technology 9-seater. That makes it possible. And of course, as the battery technology continues to improve beyond that, and it will, and the track record has been solid, and we see it going forward into the future. Higher, faster, retrofitting back onto the 2-seater and the 4-seater as well. The benefits just keep kind of flowing out as these technologies mature. There will no longer be equivalency with electric and the legacy aircraft. Electric aircraft will bypass legacy aircraft and their performance.
Wow. That's so impressive.
Yeah, it's very impressive, and it's very exciting too, because there's so much R&D, so much research and development that goes into these things, and I'm expecting to see quite a few substantial jumps in terms of the technology that can be applied. That's going to be exciting to follow.
Pilot Talk, available on iTunes, Spotify, or osmaviation.com/podcast.
What about the competitors now? You're looking at Piper. You're looking at Cessna. They haven't looked at that kind of other way of energy.
Well, I can't say. Of course, I don't have insight into their engineering or what they may be looking at or not. They don't have active public programs. There have been certainly other companies. Diamond has looked at some hybrid and electric. Airbus has done some of that, kind of off and on. Others certainly will come, but at the moment, we are the leader in the world, and we're going to work hard to stay that way.
All right, absolutely. I'm surprised that nobody else is, following.
Well, again, I'm happy to say there's research out there, and I love to talk about that, because people have wondered in the past how come we're the only ones doing it.
Right.
But there certainly are other programs, light sport or experimental programs that are out there flying.
Oh, cool.
And when it comes to mobility, Tony, you mentioned, California, Los Angeles, the Bay Area. Those are very dense areas of the United States. I would assume also that natural areas to be looking at in terms of the mobility challenge would be the New York area, possibly South Florida, or what's the most, where are the biggest challenges when it comes to mobility right now in the U.S.?
Well, it is all over America. America is a growing country, and our infrastructure is aging. We're going to start with California. There's enough in California to keep us busy for years and years and years.
Yeah.
But you do point out some of the other areas that have this problem. Texas has a big problem. The Boston area has a big problem. New York, of course. The D.C. area. The list goes on and on and on. One of the great things about George's technology is that it enables us to use the almost 6,000 neighborhood airports in America.
It's true.
There are almost 6,000 airports in America. Many of them are unused because the aircraft that are in production today are just not economical to be using those airports. So not only is there a mobility problem all around America, but there is a solution also because of these almost 6,000 airports. But we're going to start with California, the Bay Area, San Francisco, and Los Angeles, and there is plenty of room to expand as the years pass.
Yeah. That sounds exciting. What do you think, Michelle?
I'm dying to try one. I'm trying to try one. I mean, it's great. When you're talking about the 6,000 airports and all that available, also it's a silent airplane, so therefore you can come in anytime during the day or nighttime. Nobody will hear the aircraft.
You don't have the community noise impacts
Right.
and concerns. About half of those airports that Tony was mentioning are in high-density urban environments.
That's right.
Which is great because that's part of the community that he wants to serve. On the other hand, those airports are often restricted at night. And one of the benefits of electric is, of course, that five-fold operating cost advantage. And you'd like to keep those airplanes flying day and night. And so it's not just passengers that you might be carrying, but cargo.
That's true.
You know, kind of the Amazon paradigm, if you will, the on-demand, rapid response cargo capability. So lots of opportunities, as Tony mentions, not just in California, but across the country and around the world. But being able to have a community-friendly aircraft without the nighttime impact is very, very advantageous.
Oh, absolutely. Absolutely.
Yeah, and we're looking at this from OSM Aviation and OSM Aviation Academy's perspective. It's really exciting because operating more locally is also going to make the career more attractive to certain people that do not consider it today.
That's right.
Because then you can work, regionally. You can come home to your family. It opens up for a whole new talent pool, which is really exciting, I think.
Yeah. Good point.
Yeah.
Good point. Something that I haven't thought about. Yeah, absolutely.
Okay. Well, this has been extremely exciting. Really interesting to pick your brains and to take part in the journey that you are on right now. We are very much together in it with you and excited about the road forward, or the airway forward, I should say.
There we go. Airway.
Yeah.
Airway.
What
a vision.
Yeah, very, very exciting. Beautiful. And I think here to wrap things up, is there anything you gentlemen would like to add to the discussion that we haven't touched upon?
Well, I think the way forward is one of the synergy that we talked about, the collaboration between us. Tony mentioned, of course, working together with you. And I think for Bye Aerospace, for Tony and Quantum, all of us together create the possibility of the future. Not one of us alone, but all of us together, collaborating, synergizing our energies, focused together. It is hard to do. Pioneering, by definition, is hard to do. Road building or airway building.
I love that. Yeah. Well, you're totally right. It's definitely it's going to be big.
Yeah. Wise words.
I would add in closing, if I may, that many new technologies, the early adopters are the wealthy folks and the people with money, and I think that will be the case with this new vertical takeoff and landing technology that Uber is pushing. But with George's technology, with these electric fixed-wing aircraft, because of the low operating costs, and because of the fact that it's a perfect solution for commuters, ironically, the people who will benefit first from this will be the working class people. And one of the things we're very, very proud of is that we're going to be able to bring this solution first to the people who need it most, the working class people. And so it's truly going to be something that not only the three of us can collaborate on and enjoy, but that many, many other people who aren't necessarily wealthy can enjoy also. And I'm really, really looking forward to bringing that service to our communities and making a difference in our communities.
Absolutely. Well said.
Perfect.
Well
That's
said.
a good a note as any to wrap up these discussions. And let me just, on behalf of Michelle and I and OSM Aviation, thank you so much for this conversation here today and for sharing your knowledge and insights with our listeners across the world.
My pleasure.
Thank you.
Thank you very much. Thank you.
Thanks.
Pilot Talk. Everything you need to know about being a pilot.
Okay, that's a wrap for today's episode. Thank you so much for listening. We hope you enjoyed it as much as we did. Don't forget to follow the Pilot Talk podcast on Instagram for behind-the-scenes material. And there you can also send us feedback, ideas, questions, and we're going to have competitions from time to time where we give away free stuff. As always, you can find our podcast on Spotify, iTunes, Podbean, anywhere where podcasts can be found. And you can also tune in via your browser at osmaviation.com/podcast. And what do you got to say to sum up today's episode? Electric aviation, huh?
It's incredible. I wish we could have had more time with George and Tony.
Yeah.
But for the listeners, listen, we probably will have another one in the future.
Yeah.
Because it's such an interesting subject, and it's something that it's dear to our heart because we are involved in the training of the pilots for George, for Tony, and George is, it's all three of us.
Yeah, we're in this together.
Yeah, it's going to be incredible. So I think that we might do some follow up on that. So on that note, I want to wish everybody blue sky
And happy landings.
Bye.
Ciao.